Hello, I am Miss Janice. In the previous lesson, we have learned how to find the derivative of a trigonometry function. Now we need to move on to learn how to find the derivative of an exponential function. First of all, we must know what is an exponential function. Do you know? An exponential function is actually a function in the form of fx to the power of gx. This is the base. Fx is the base. The base can be of any function. It can be x term, it can be a constant. But for an exponential function, the power of the base must be a function in terms of x. The power cannot be a number. It must be a function in terms of x. For instance, 2 to the power of x. See, the base here is 2, a number. However, the power is a function in terms of x. This is an exponential term. X to the power of 2x. See, the power is in terms of x. E to the power of x squared. And cos x to the power of sine x. The power is a function in terms of x for all these terms. So they are all exponential terms. To differentiate exponential term, we have to remember the formula. Differentiate e to the power of fx. It is equals to f prime x e to the power of fx. Basically, we just look at the power and we differentiate the power. We get f prime x and times the same exponential term given by the question. This is the way to differentiate exponential term. Bear in mind, to differentiate exponential term, we need to ensure the base is base e, where e is actually a number, just like pi. E is 2.71828 ... Differentiate exponential term, we must ensure it is in the form of e to the power of fx. Differentiate e to the power of fx, it is equals to f prime x times e to the power of fx. So now, how do you differentiate e to the power of x? First, this is an exponential term because power in terms of x, and it is already in base e. So the rule is we need to differentiate the power. In this case, the power is x, so differentiate x times the same e term, which is e to the power of x. What do you get? Differentiate x with respect to x, we get 1 times e to the power of x. So take note, differentiate e to the power of x will give us e to the power of x. What about differentiate e to the power of 2x? Exponential term, because power in terms of x, and it is already in base e. So follow the formula, we need to differentiate the power, differentiate 2x times the same e term, e to the power of 2x. Differentiate 2x, we get 2 times e to the power of 2x. So differentiate e to the power of 2x, it is equal to 2e to the power of 2x. Remember this rule for derivative of exponential function. Move on, let's talk about derivative of logarithmic function. Log function, log, is logarithmic function. When we have log to the base e of x, it means it is ln x. Log to the base e of x equals to ln x. We call it as natural logarithm. There is a formula for differentiation of logarithmic function. Differentiate ln fx, it must be natural log, log base e. This is a must. In order to apply this formula, will give us a fraction as the answer. Differentiate ln function will give us a fraction as the answer. The fraction is in the form of f prime x over fx. So when you differentiate ln fx, you ask yourself, what is ln carrying? Here ln carry fx. So we write fx as the denominator. Look at the fx. Differentiate it and the derivative, we need to write it on the numerator, denoted as f prime x. So what do you get if you differentiate ln x? Differentiate ln x will give us a fraction. Ln here carry x, so I write x as the denom. Differentiate x, we will get 1, write it on top. Therefore, differentiate ln x is 1 over x. What about differentiate ln 2x? Differentiate ln 2x, what do you get? It will be a fraction because differentiation of ln function must be a fraction. Here, ln carries 2x. We write 2x as the denominator. Differentiate 2x, what do you get? We get 2, so put it on top. Simplify further, we get 1 by x. Here we notice differentiate ln x is 1 over x. Differentiate ln 2x is also 1 over x. How come they carry the same value? This is very simple because for ln 2x, we follow the properties of log. We have ln a times b. It will be equals to ln a plus ln b, right? So I follow the properties. Ln 2 times x will be equals to ln 2 plus ln x. So when we differentiate ln 2 plus ln x, what do you get? For ln 2, it is a constant, just a number. When we differentiate a number, we get 0. So differentiate ln 2 is 0. Plus differentiate ln x, this is log function. Ln carry x, so we write x as the denom. Differentiate x, we get 1. Put it on top. So overall, differentiation of ln 2 plus ln x will give us 1 by x. This explains why ln x and ln 2x will have the same derivatives. So differentiate ln 2x will be equals to 2 over 2x, which is 1 by x. Let's see the example on derivative of exponential and log function. Number 1, in example 8, find the derivatives of y equals to 1000 times e to the power of 7x. First of all, we question ourselves, what type of function is this? This is an exponential function because the power is in terms of x. So the derivative, which is y prime, also can be written as dy over dx will be equals to, it's already in base e, so we can apply the rule now, where the rule tells us differentiate e to the power of fx is equals to f prime x e to the power of fx. So we keep 1000 because 1000 here is the constant multiple. Let's differentiate e to the power of 7x. We need to differentiate the power, which is differentiate 7x times the same exponential term. So overall, we have 1000 times 7 e to the power of 7x. Further simplify, it is 7000 e to the power of 7x. For number 2, y equals to x squared times e to the power of x. This is a product. X squared times e to the power of x. So we let x squared be u, e to the power of x be v. We need to apply product rule. So u prime will be equals to 2x. V prime means differentiate e to the power of x. We get e to the power of x. With u, v, u prime, v prime ready, we can apply the product rule to get the derivative. Dy over dx equals to u prime v plus u v prime. Substitute u prime, which is 2x v e to the power of x, plus u v prime. So we factorize completely x e to the power of x. So we get 2 plus x. This is the final answer. Move on to number 3. Y equals to sine e to the power of cos x. There are trigo as well as exponential term here. So what is the leading function? Here the leading function is the trigo term. This is actually like trigonometry term sine fx, where e to the power of cos x is actually the angle. So it is like differentiate sine fx. Recall how to find the derivative of the trigonometry term. Differentiate sine fx. It involves 2 steps. Differentiate sine, we get cos of the same function. First step. Then we need to multiply the derivative of the angle here. The derivative of fx, which is f prime x. 2 steps involved. So we start to differentiate sine with the angle e to the power of cos x. Dy over dx will be equals to cos of the same angle. Differentiate sine, we get cos. Then we need to times the derivative of the angle, which is e to the power of cos x. Continue, copy the same term in front. Now, to differentiate e to the power of cos x, recall the rule, differentiate e to the power of fx, what do you get? You get f prime x times e to the power of fx. So we need to differentiate the power, which is cos x here, times the same e term, e to the power of cos x. So continue, simplify it, cos e to the power of cos x times, differentiate cos x, we get negative sin x times e to the power of cos x. Continue to simplify the answer. So overall, it is negative cos e to the power of cos x times sin x e to the power of cos x. Number 4, fx equals to 2e to the power of x squared minus 5e to the power of negative x. There are two terms here, both are exponential terms because the power in terms of x. They are all already in base e. So we continue to get the derivative. F prime x will be equals to, for the first term, we keep 2, which is a constant multiple. Then we need to differentiate the power, differentiate x squared times the same e term, which is e to the power of x squared. Minus 5 is a constant multiple keep. We need to differentiate the power times the differentiation of the power, which is negative x here, times the same e term. Continue, 2 times differentiate x squared, bring the power down, power minus 1, e power of x squared, minus 5, differentiate negative x, we get negative 1, e to the power of negative x. Further simplify, we have 4x e to the power of x squared plus 5 e to the power of negative x. More examples. Y equals to 3 to the power of x. First of all, this is exponential term because of the power x. But the base is not base e. How do we derive this function? We have to change this term to base e by using a rule. For your information, if you have a, it can be converted to a term in base e, where you just need to change it to e to the power of log a. If it's b, convert b to base e, how? E to the power of log b. If it's c, convert to base e, e to the power of log c. Alright, so we can convert any term to base e, follow this rule. So here I need to differentiate exponential term, and I need to ensure that the base is base e. So there is a need to convert 3 to the power of x to base e. So I let this be equals to a for 3 to the power of x. Convert a to base e, it will be e to the power of log a, which is replace a back to 3 to the power of x. So it is e to the power of log 3 to the power of x. Right? There are 3 levels here. Look at log 3 to the power of x. Log 3 to the power of x. We have learned from pre-cal, when we have log a to the power of b, the power b can be brought forward. So we have b times log a, right? Therefore, log 3 to the power of x can be written as x times log 3. So we bring this power x to the front. It will be e to the power of x times log 3. Right? Hope you get it. Now, I have converted 3 to the power of x to base e, which is e to the power of x log 3. Now, differentiate this function. Differentiate y, we get dy over dx, right? So how do we differentiate e function? The power is x times log 3. So to differentiate the exponential term, we need to differentiate the power, which is differentiate x times log 3 times the same e term. What do you get when you differentiate x times log 3? Log 3 is just like a number. So x times log 3, it is like x times a constant. Differentiate cx, you will get c. Differentiate ax, you will get a. So here I will get c, which is log 3. Because log 3 is just like a number. So copy back the same e term. Therefore, this is the answer. However, I will always have a habit to change it back to the original term. Ln 3 stay. E to the power of x ln 3. E to the power of x ln 3 initially is e to the power of ln 3 to the power of x, which is equals to e to the power of ln a. That is a, 3 to the power of x. Change it back to 3 to the power of x. See, this is quite complicated. When you differentiate an exponential term which is not base e, your job is to convert it to base e. Then only you can start to apply the formula to differentiate an exponential term. Let's try one more example. Y equals to x to the power of sine x. Again, the power is in terms of x, but the base is not base e. So I need to convert to base e first. According to the rule, when we have x to the power of sine x, to convert to base e, I will call out e to the power of ln x to the power of sine x. For ln x to the power of sine x, this power can be brought forward. So it is e to the power of sine x ln x. Now, we have converted the exponential term to base e. Continue for the differentiation. Differentiate e term, we need to differentiate the power. Here the power is sine x times ln x. And times the same e term, which is e to the power of sine x ln x. How do you differentiate sine x ln x? To differentiate sine x ln x, we need to apply product rule. This is u, this is v. U prime equals to differentiate sine x, we get cos x. V prime, differentiate ln x. Remember, when we differentiate ln x, we will get a fraction. Ln carry x, we write it as denom. Differentiate x is 1, we put it on top. V prime is 1 by x. So apply the product rule. U prime, v plus u, v prime, times the same e term. E to the power of sine x ln x is originally e to the power of ln x to the power of sine x, which is originally x to the power of sine x. So I write down x to the power of sine x. There is nothing to be simplified, even though if we expand in full. So we leave the answer as it is. More example. Now, for derivative of logarithmic function, take note, recall the formula. Differentiate ln fx will give us a fraction. Ln carry fx, write fx as the denom. We need to differentiate fx and get f prime x. We have to write f prime x on numerator side. Number 1, y equals to ln x squared. So what do you get for your dy over dx? Ln carry x squared, so write x squared as the denom. We need to differentiate x squared and put it on top. So differentiate x squared, we get 2x over x squared. Further simplify, we get 2 by x. Number 2, y equals to ln secant x. The derivative for this function will be y equals to ln secant x. Ln carry secant x, so we will write secant x as the denom. And the top part, we will need to differentiate secant x. So differentiate secant x, we will get secant x tangent x over secant x. So further simplify, we will be having tangent x as the final answer. Continue. Number 3, y equals to x times ln x. It's a product here, u times v, where u equals to x and v equals to ln x. U prime will be differentiate x, we get 1. And v prime, differentiate ln x, we get 1 by x. So we substitute into the product formula. dy over dx will be equals to u prime v plus u v prime, which is 1 times ln x plus x times 1 by x. Further simplify, we get dy over dx equals to ln x plus 1. Number 4, fx equals to e to the power of x ln x. This is an exponential term, and it is already in base e. So the derivative f prime x will be, what do you get? How do you differentiate exponential term? Recall the rule, differentiate e to the power of fx. We will get f prime x times e to the power of fx. So we need to differentiate the power here, which is x ln x, times the same e term, e to the power of x ln x. How do you differentiate x ln x? This is a product. We have done it earlier in number 3, where u equals to x and v equals to ln x. This is u, this is v. So we apply the product rule for the derivative of x ln x. Differentiate the first one, we get 1. Copy the second one, plus copy the first one. Differentiate the second one, which means differentiate ln x. We get 1 by x times the same e term, e to the power of x ln x. Further simplify, the answer will be ln x plus 1 times e to the power of x ln x. More example. Number 5, fx equals to 2 ln x over x. This is a quotient, u over v. U equals to 2 ln x. Therefore, u prime will be 2 is a constant multiple we keep. Differentiate ln x, we get 1 by x. And v equals to x. V prime will be 1. Differentiate x, we get 1. So the derivative for number 5 will be using the quotient rule, u prime v minus uv prime over v squared. Let's substitute u prime v, 2 by x ln x minus u, 2 ln x, v prime, which is 1 here, over v squared, x squared. Continue, we need to further simplify. This 1 over x squared, I drag it out. X squared, which is denominator, I drag it aside, and times 2 by x ln x minus 2 ln x. This is the final answer for number 5. We cannot leave the answer in 3 levels. Number 6, y equals to log base 2x. We know the derivative formula for ln fx. It must be log to the base e of fx. That is equals to f prime x over fx. What about log to the base of 2x? We need to change the base. From the earlier lesson in pre-calc, when you have log to the base a, b, you can change the base to any other base. So it will be log base c, b over log base ca. So let's change the base to base e. So this will be log base ex over log base e2. That is written as ln x over ln 2. Here, what I am doing is I change the base to base e. Then I pull the denom, which is a constant, aside. This is actually 1 over ln 2 times ln x. So the derivative for this function, dy over dx, will be equals to, how do you differentiate 1 over ln 2 times ln x? 1 over ln 2, it is just a constant multiple. So I keep it, times the derivative of ln x, we get 1 over x. So this is the answer. Or if you want to combine, we should write it as 1 over x ln 2. Number 7, similar to number 6, this is log function, but it is not log base e. So we need to change the base first. Negative 8 stay. This is actually log base e 2x plus 1 over log base e 5, which is actually equals to negative 8 over ln 5. I will pull this denominator aside, times ln 2x plus 1. I prefer to pull this ln 5 to the side because it is just a constant multiple. So I prefer to have the constant multiple at one side on the left before I differentiate. So this is just the modification where I change the base fx. So now we start the derivative. F prime x will be equals to, look at this for differentiation. Negative 8 over ln 5, it is just a constant, a number, a constant multiple to this ln term. So I keep negative 8 over ln 5 times, let's differentiate ln 2x plus 1. We know that when we differentiate ln fx, it is equals to f prime x over fx. Here ln carry 2x plus 1. So I write 2x plus 1 at the denominator. Differentiate 2x plus 1. Differentiate 2x, we get 2. Differentiate 1, we get 0. So equals to, further simplify, negative 16 over ln 5, 2x plus 1. Number 8, fx equals to x to the power of pi. This is not an exponential term because the power is not x term. The power is a number. So it is just like x to the power of 3.142. So when we differentiate, this is just the normal x term where we need to follow the rule, bring the power down, power minus 1. Or if you prefer to write in number form, the derivative of x to the power of 3.142 will be equals to 3.142 x to the power of 2.142. Because 3.142 minus 1, we get 2.142. So it is just like differentiate x to the power of n term, n times x to the power of n minus 1. Number 9, y equals to x plus 1 to the power of e. The power is e. It is not a function in terms of x. E is a number, 2.71828. So when we differentiate x plus 1 to the power of e, it is the basic differentiation. Bring the power down, the same term, power minus 1, and we need to times the differentiation in the bracket. We apply power rule here. Therefore, we get e x plus 1, e minus 1. Differentiate x is 1, differentiate 1 is 0. So it is 1 plus 0. And the final answer will be e times x plus 1 to the power of e minus 1. Number 10, fx equals to ln 2x over x minus 1. So here, ln carry a quotient. I will apply the properties of log before I start the differentiation, where we know that ln a over b equals to ln a minus ln b. So I apply the properties. It will be ln 2x minus ln x minus 1. So we differentiate these two terms individually. Differentiate ln 2x. Ln carry 2x. Write 2x as the denom. Differentiate 2x. We get 2. Put it on top. Minus. Differentiate ln x minus 1. Ln carry x minus 1. Write it down. Differentiate x. We get 1. Differentiate negative 1. We get 0. Overall, we have 1 over x minus 1 over x minus 1 as the final answer. If the question asks us to write the answer as a single fraction, then we have to make the denominator the same. So for this one, we multiply x minus 1. And for this, we multiply x. So x minus 1 minus x over x minus 1. Make the denominator the same. So overall, we have x minus x gone, negative 1 over x minus 1. This is the final answer. That is all about the derivative of exponential function and log function. We need to remember that when we differentiate exponential function, which means the term has power, which is a function in terms of x, it must be base e. So when we differentiate e to the power of fx, the answer must be f prime x times e to the power of fx. If the function given is not base e, say x to the power of x, we need to convert it to base e by putting e to the power of ln x to the power of x. And make sure you bring the power down in front of ln, where you will get e to the power of x times ln x. Convert the exponential term, which is not base e, to base e in order to differentiate it. And for derivative of log function, differentiate ln fx will not give us ln as the answer, but the answer must be a fraction. Ln carry fx, we put fx as the denom. Differentiate fx, we have f prime x, put it on the numerator part. Thank you for the lesson.